Okay, going here on our 7G notes. I want to go over the rules really quickly, and then I'll do all the practice problems on the back, and that'll help you guys do 7H notes for homework tonight. Um, so now we're talking about different angles that are in circles that are not in the center. So there's different rules. If you recall, going back to the 7E notes, if I had an angle in the center of a circle, which was called a central angle, that angle would be equal to the arc that it created. So if I had a 90-degree angle in here at the center, I would have a 90-degree arc here. Now, where the location of the angle is going to sort of dictate how we measure the arc, okay? So the first thing we have are inscribed angles, and inscribed angles are angles where the vertex is on the circle. And if that's the case, the angle is going to be half the arc that it intercepts, okay? So here, if I'm looking at angle B, angle B is an inscribed angle because the vertex is on the circle, and it intercepts this arc AC. All right, so the angle, the vertex is on the circle. It's half of the arc that it intersects. It's half of 60, so angle B is going to be 30 degrees. Okay. Um, these ones, okay, again, the rule is the angle is half of the arc that it intercepts. So here, the angle is 63 degrees. So if angle is half of the arc, we know that the arc is going to be double the angle, okay? So here we'd multiply 63 times 2 to get the arc 126 degrees, okay? On this third one, same deal. I have an inscribed angle that's 57 degrees. Okay, the angle is half of the arc. So since I have the angle, I'm going to double that number to get the arc. 57 times 2 is going to be 114 degrees, okay? So that's that put simply there. Okay. Next, if I have an angle that is on the inside of a circle, all right, formed by two chords, it's going to be half the sum of the intercepted arc and the intercepted arc of the vertical angle. Okay. So if I'm looking at angle X right here, so we see angle X, the vertex is inside the circle, but it's not in the center. Okay, it's inside the circle, but not at the center. So I'm going to take angle X, I'm going to trace out where the angle creates an arc, okay, and it's going to create this 90-degree arc right here. Now, we have to add that 90-degree arc with the arc from its vertical angle. So we know this angle is X right here. This angle that's across from it is also X. And that angle X creates a 50-degree angle, okay? So what we're going to do is we're going to add these two arcs, 90 plus 50. Divided by 2, because it's going to be half of the sum of that. So 90 plus 50 is 140 divided by 2. Because angles X is going to be 70 degrees. All right. If we're looking at the other angle, angle Y, so here's angle Y. Angle Y comes up to the 60-degree arc. All right. And then the vertical angle to angle Y, which is down here, goes to this 160-degree arc. Okay. So to find angle Y, it would be 60 plus 160 divided by 2. 60 plus 160 is 220 divided by 2 is 110 degrees. And we should know that angle X and angle Y here, they form a straight line, so they should add up to 180. And our two answers do just that, 70 plus 110, add up to 180. So that's a good way to sort of check, okay? So when the vertex of the angle is inside the circle, you have to take the two arcs that it creates, add them up, and divide by 2, okay? Lastly, when we get down here, if I have an angle where the vertex is outside of the circle, the measure is half the difference. Okay, it's half the difference, and of course, difference means subtract. So half the difference of of the two intercepted arcs. Okay, so if we're looking for angle D is going to intercept two arcs. If I trace this out, it's going to intercept this arc CE. Okay, and if I continue to trace this out, it's going to intercept arc BF. All right, so angle D, we're going to take the two arcs 95 minus 35. Ugh. And we're going to divide that by 2. $95 minus 35 is 60. And we divide that by 2, so angle D is going to be 30-degree angle. Okay. Over here, we're looking for angle J. Again, angle J, the vertex is outside of the circle. So if I trace angle J out, okay, I have a 50-degree arc, and I have a 130-degree arc. Okay, so we'll go 130 minus 50, and we'll divide that number by 2. 130 minus 50 is 80, divided by 2, it's 40-degree arc. Okay. Here on this last one, we have angle M. It's on the outside of a circle. Okay, it's going to intercept two arcs here. All right, the first arc here is 125 degrees. All right, and the other arc is going to be 235 degrees. Okay, so both of these lines sort of end on the circle N and O, which is something that we'll talk about a little bit later. But angle M creates this small arc here, 125, and that bigger arc, 235. So 235 minus 125, and we'll divide that by 2. Okay, 235 minus 125 is 110, and we divide that by 2, so angle M should be 55 degrees. Okay, going to the back. I'm going to do a couple of these here on the back. So measure of angle 1. Okay, angle 1. I'm going to put this picture up easy for me to write. So angle 1 is inside the circle, and angle 1 creates a 56-degree arc and a 50-degree arc. Okay, so when the angle's on the inside, we add the two arcs, 50 plus 56. And divide it by 2. Okay, on the next picture, we have angle HFG. Again, on the inside of the circle. Okay, and I have the two arcs, 23 and 59, so we'll go 59 plus 23 and divide it by 2. Okay, again, going back to the rules from the first page. Okay, I'm going to skip down to number 5 here real quick. Number 5, so we're trying to find the measure of angle 5, right? Well, the problem with angle 5 is that we don't have either of these two arcs, okay? But what we can do is I'm going to put an angle X right here, all right? So an angle X right here, which is next to it, which also forms a line with it. Now we can find the measure of angle X, okay? So angle X will be 66 plus 50 divided by 2. All right, so 66 plus 50 would be 115, or 116, excuse me, divided by 2. So this angle X here would be 58 degrees. And we know that this angle 5 is going to be 180 minus 58 degrees, which is going to be 122 degrees. Okay, everything should be pretty simple so far. Okay, next, angle 3. The vertex is on the circle. It's an inscribed angle. Okay, inscribed angle is half the arc that it intercepts. Okay, so angle 3 is going to be half of 198. So let's do 198 divided by 2 to get angle 3. Okay, angle 4.